In this video, I'm going to go over environmental epidemiology, as well as share how epidemiology has contributed to the field of environmental health, as well as limitations of that it has. And then I'm going to follow with an example of how I've used observational data to explore an environmental health issue in a community in Romania. So by definition, the environmental epidemiology is the study of diseases and health conditions occurring in the population that are linked to environmental factors. These exposures are usually involuntary and stem from ambient and occupational environments. The different contributions that epidemiology has had to environmental health are particularly concerned with populations. So it's sometimes even called population medicine. And then another area is the use of observational data. And environmental epidemiology has even sometimes been called an observational science, and that's where I will provide an example later in this video. The methodology for study designs is another major contribution. Standard epidemiological methods are used to study the association between different environmental exposures and health outcomes. So the different study designs I won't be going into in this video, but they are outlined in your textbook. They're applied in also in an activity on Moodle, but they could include case control studies, prospective and retrospective type studies, case series, and things like that. Some example topics of environmental epidemiological studies could be involve issues around air and water pollution, or the occupational environment, where you're looking at physical and chemical agents, and even the psychosocial environment. And then finally, there's both descriptive and analytic studies. So this is really, really useful, and I will discuss that more in a minute. I do want to just highlight a couple historical figures that are key in this area. First is Sir Percival Pott. He was a London surgeon, thought to be the first individual to describe an environmental cause of cancer. So he saw that chimney sweepers were having a higher incidence of scrotal cancer due to contact with soot. But it was before he realized it was contact from soot, he just saw that there was a higher incidence of scrotal cancer compared to men in other occupations. So later he was able to determine the cause, that it was soot, and then ultimately make public health recommendations for workers in this occupation to shower after work, and to different ways to minimize their contact and exposure with the soot. Second major figure is John Snow. He linked a cholera outbreak in London to contaminated water, and he was the first to employ a natural experiment. And this methodology is currently used in different studies to study environmental health problems, and actually is sort of what I also used in my study design as well. So you'll see an example in a minute. He also used both descriptive and analytical approaches to his study. So this is a map that he had created, and he mapped the different cases here. And so these were the number of cases of cholera, and this was where the water was accessed from. So what he did, how he used both descriptive and analytic type approaches. In descriptive studies, you're looking at the occurrence of disease in populations by classifying things by person, place, and time. So in the map, he was mapping the cases by place and time variables on that map. Then by linking it to the pump and realizing that the pump had been changed to a different water source, he was able to get to the why, or the cause. So the analytical aspect is actually examining the causal hypothesis regarding the association between the exposure and health condition. Another contribution is this epidemiological triangle, and it's helpful for describing the causality of infectious diseases, and really provides a framework for viewing hypothesized relationships among the agent, host, and environmental factors. So it looks like, I'm not sure if you're seeing my screen down here, but on the bottom right is the environment, and that is going to be defined as the domain in which the disease causing agents may exist, survive, or originate. And it consists of all that is external to the individual human host. So if you can't see it and you're seeing my thing here, it is the environment. And then the host is going to be a person or other living animal, including birds and arthropods that afford subsistence or lodgement to an infectious agent under natural conditions. And then this bottom left of the triangle is the agent, and that is the factor that could be like such as a microorganism, chemical substance, or even form of radiation, whose presence, excessive presence, or even absence of the factor is essential for the occurrence of disease. So this may be good for kind of mapping out and providing a framework for different hypothesized relationships, and even with your risk assessment project, for example. So using observational methods to identify environmental health risks, as I mentioned, was a key contribution of epidemiology to the field. Particularly environmental epidemiology is primarily an observational science, and it takes advantage of those naturally occurring situations, similar to that natural experiment that John Snow employed. These are used to study the occurrence of disease. The majority of research on human health that is associated with the environment does use observational methods. Limitation from this is that you really need to often use non-randomized design. When you use, if you try to do a randomized control trial, you can't ethically put somebody in harm's way and expose them to things in the environment that potentially could cause them harm. So you do have the problem of inferring causation because of that design. You can choose the exposures to study, but you can't influence them. And so I want to take you to a community in Romania. It's the name of the community I'll show you is Dallas, which is a sub-community of Patarat. But they were 4 communities that live and work off of the community landfill there. It has since closed, but it was open when I was there, and there's still some Roma scavenging there. So that is a Roma community. Sometimes people refer to them as gypsies. That is not the appropriate way. They prefer to call Roma or Romani. But here I'm walking through, I used photography and a little bit of photo voice to observe and get information. I did some other methods of community mapping and interviewing to get at some other aspects that I was exploring, but for the sake of time and just kind of highlighting the observation side, I'll show you a few pictures here. So this is one of the water wells, and you can see the waste that is built up around it, excuse me. And these children are washing themselves off, washing raw meat here on the left, but they did a variety of activities right at the well site. This is another view from this water well so you can see just the buildup of all of the waste and the potential for that to then go into the soil and ultimately into the water supply. These are a couple of pictures of down inside the well, so you can see the plastics and the waste that are down in the well. And these pictures were actually taken by a Roma adolescent or teenager who went with me and was participating in a photo voice activity. So I would have never gone down there. So that was another element that I was able to gather. This is another water well and just a view of the community to see the waste that is built up, the stagnant water. So you can see there's a number of environmental health issues going on here, but the contact with different chemicals is likely potentially from the water supply, for example, in these here. These are pictures of just closer up and then down inside the well of this picture, or that well, excuse me. And then this is another well, and I pulled this one out in particular to show and highlight the latrine here, that it is uphill and it is in close range, not where you want to have a latrine. And here's an animal living quarters. You can see the behind of the horse. So you're going to have feces coming down from here and potentially entering that water supply as well. Then over here, you see that the housing and the child here is pretty dirty. did not, of course, have running water. They had the water wells, and they scavenged and worked in the landfill. So they were pretty dirty, and it was very difficult to get some of that contaminated soil off of them. But one of the ways that it became so contaminated, here's a burn site, and I'm going to go into it further. There was also a burn site up here, but they burned the electrical wiring. Oh, that was just another picture of inside that water well that's broken, but they burn the electrical wiring to get the metals and recycle them. It's the most lucrative recyclable for the community in terms of how much money they can earn. And so you can see them, and it's just open burning, and how there's children, there's a pregnant woman here, and the chemicals that are released during that burning process of the rubber and plastic that's being burned. The smells were really, really strong. I don't usually get headaches, and I had really, really strong headaches while I was there, especially when burning was going on. And so these are just a couple other pictures of them burning. But when they do that, the wiring releases multiple chemicals here: dioxins, furans, hydrogen chloride, and phosgene. We know there's multiple pollutants in smoke, including particulate matter and carbon monoxide. And so you put these together, and there's strong evidence already in the literature that shows there's respiratory effects, even potential birth defects, cancers, learning disabilities, and effects on immunity and the endocrine system. So what I did, again, I used some other methods, but through observation and photography and photo voice, and of course, looking back through literature, I was able to determine the chemicals that were going to be most likely to be found in the community, as well as the exposure routes for these chemicals. So what is concerning is that some of these can be exposed in all these 5 routes here. So I have air, smoke, water, dust, soil, and food. So arsenic, copper, lead, and zinc all can pass through all 4 exposure routes. And so exploring these in more detail and trying to find causes would be a next step. And then you can see some of these, the ones with the stars, the chemical can pass through soil into groundwater. So with that waste, and if any of those, or even the burning, if that chemical is released from that. So for example, they would burn shoes in the winter a lot to get, they lasted longer. So for heat, or to melt ice for drinking water if it had frozen. And then some are going to depend on the compound and soil characteristics. So there's limitations in this study, and there's limitations faced by all epidemiologists when they study the relationship between exposure and disease outcomes when you're looking at community environmental pollution. And so these are in the textbook there, the article, Climate Change Epidemiology and the Methodological Challenges provides some really good limitations and challenges as well around epidemiology and environmental health. But I'm going to highlight just a couple here. One here at the top, the long and variable latency periods between exposure and disease diagnosis. It's really difficult to, some of these, depending on the time and route of exposure, and the dose, it's very difficult to make that causal link. For example, and it can be decades before you can make that link. So my father was diagnosed with cancer in 2003, but he was in Vietnam in the 70s. His cancer was later determined to be 100% linked to Agent Orange from Vietnam. So you're looking at about 33 years before that was found. And when it was found, it was stage 4, and he was given 6 months. So there was not a lot of time, but they were able to determine that it was from Agent Orange because of where he was at and how much spraying had been done in his location of Agent Orange, and then where it was in the lining of his lung. So 30, 40 years, it's very difficult sometimes to go back. His was a little more clear than maybe some other cases. So that is a major limitation. Also, just the specificity of disease and being able to make that cause. A bias, of course, is going to be a pretty big limitation. And this is going to occur even in the design of studies and the implementation of them, and in the analysis and reporting as well. There is also now more and more usage of GIS mapping and the use of geography in creating maps to provide some more objective type data and visuals around some of the environmental health issues. And so that there's that, but again, observer bias is going to be, especially when we're thinking of it as an observational science, that who's ever observing it is going to bring bias into that. Then there's just limitations in knowing, we are exposed to hundreds and thousands of chemicals every day. And most of them are probably low dose levels and in different settings. So it's really difficult to be able to make a causal link to say that one specific chemical caused a specific disease. So it's hard, you can't isolate, it's very difficult to isolate one chemical when we're exposed to so many. So that is a major limitation as well. That's where we see a lot of some of the more the progress around causal links a lot of times have been in occupational environments, similar to Percival Potts' observation with the chimney sweepers. If a person is exposed 8, 10, 12 hours a day, 4 or 5 days a week to something, and their rates are higher, then you can make a causal, more of a causal link that way. But in general populations, it is a lot more difficult. So the other thing here is to, again, review these limitations in more detail, but I wanted to highlight them because when you're reading your articles and the studies for your risk assessment project, you definitely want to take note of the limitations in the study design, as well as the limitations as it applies to what you're studying, and those should be reported in your risk assessment as well. It also may affect if you include the study or not, thinking about how many participants were in the study, because some of them are very small population sizes, as you can see in that third one of the limitation there. So deciding if it's too small to show a cause to include. Another thing too, in when you're reading your articles and doing the research for your project, is to keep in mind too the different study designs in epidemiology, and deciding the strength of those in what the author is portraying, if there's a cause or not a cause. So this short video was just to introduce environmental epidemiology to you and provide a more visual example of how it's been used and how I've used it, and then highlight that there are limitations and faced by researchers, and to make sure to consider those limitations as you do your own risk assessment project for the class.